Hello, dear students. I'm Aditya Gupta, and a very warm welcome to this lecture on triangles. In the last lecture, we have basically seen, the different criteria that can be used to prove congruence in triangles. Now, in this particular lecture, we'll be looking at mainly some good examples, good questions and illustrations to understand and solve using congruence of triangles, right? So let's get started. Yeah, topics to be covered, questions on congruence criteria. Now let's have a look at this question. We are given in the figure sides BA, okay, side BA and CA, they are equal, okay, and BA equal to AD, fine. Then what else is given to us? We are also given CA equal to AE, right? So CA equal to AE, and we have to prove that DE and BC are parallel, right? So immediately, what do we observe in these two triangles? That, of course, these will be equal angles because they are vertically opposite angles. So side angle side, side angle side, what are we observing? SAS, right? So we should be able to, since we have got this idea, we can just prove them congruent using SAS. Let us say the top triangle's name I write in this manner, triangle EAD. Then in what manner should I write the second triangle's name? That is important, okay? Because the order and the congruence order of the points is very important, right? So of course the point A should come in middle only, because angle A equal to angle A here also, correct? Because they are vertically opposite angles. This we are doing in rough, okay? This we are doing in rough, so that we already know what the congruence criterion. And then the in fair work we will write SAS in the correct order, okay? Now what point should come here? Either C will come or B will come, right? Let us assume that B will come, then it will become BAC triangle, right? But is it true that EA equal to BA? EA equal to BA is not true. So this is incorrect. So it must have been C must have come here and B must have come here. Now it's true. EA equal to CA. EA equal to CA. Yes, that's true. So in rough, we already know this must be the order. Now in fair work, we will write, and we also know already that side angle side has to be used because this angle is included between these two sides, right? So let us first write the side one that we are talking about, which can be, let's say, if I write AD, okay, from this triangle, then it must come AB, correspond, because AD, second letter, third letter, second letter, third letter. So that way it will come, right? So we have written in exactly the correct order, AD equal to AB, and that is true also, of course. So, and we'll write the reason as given. This is given to us, AD equal to AB. Second, we will write angle, okay. Angle we will write, of course, that angle will be this angle A. So how will we name this angle? We can't just call it angle A, because there are two angle A's here, okay? So we should rather call this angle, let's say angle EAD, if we are calling it. Then EAD angle is this. Then correspondingly, what angle is coming? EAD CAB should come. CAB, and that's true also. These two angles are actually equal, and reason we'll provide, vertically opposite angles are equal. Finally, the side will come for SAS. Second side will come, which includes this angle. That will be obviously EA, right? So EA side should be equal to CA. So yes, that is true also, because it is given to us, and hence by CPCT, by not by CPCT, implies triangle EAD will be congruent to triangle CAB by SAS congruence criterion, right? Now by CPCT we can say that angle, what will be this angle? Look, if we want to prove these two lines parallel, can we say we want to prove this angle and this angle are equal? Because alternate interior angles are equal, then lines are parallel, right? So by CPCT, what should we call this angle here? Either we can call just angle E, and here we will get angle C. Angle E equal to angle C, correct? So this implies that DE will be parallel to BC since they are alternate interior angles. Angles are equal, okay? Because they are equal, so it will be parallel, hence the question has been solved. The same solution we are given here, that using SAS congruence criterion, they have proved these two triangles as congruent, which is absolutely correct. Because if they have named this triangle as BAC, so if we name it as BAC, then here we will get DAE, and here they have correctly written down DAE. So the order is correct here also. Now, corresponding parts are equal, so we can conclude that DEA and BCA, these angles, basically angle E, angle C, are equal because they are alternate interior angles. So it means that the lines will be parallel also, hence proved. Fine. So I hope this particular question is clear to all of you. Now let us talk about this question here. In a triangle PQR, if PQ equals QR, okay, PQ equals QR, fine. M and N are the midpoints. Okay, L, M, N are the midpoints, fine. So look, we can say that since these are the midpoints, obviously QL will be equal to, and let us say this length is A, this entire length will also be A because it is given PQ equal to QR. So QL will be equal to LP, which will be equal to A by 2. But similarly, we can say MQ will also be equal to MR because it is the midpoint, equal to this entire length by 2. Obviously, both of these lengths will be half of this now because this is the midpoint. So since both of them are equal to A by 2, we can say they are equal to each other also, since all of them are A by 2. Okay. Now, what can we say? We have to prove Ln and Mn are equal. Ln and Mn we have to prove equal. So let us consider these two triangles. Okay. How can we prove that these are congruent? In what manner can we prove? One of the ways can be that since this is a isosceles triangle, we can say that if this angle is theta, this will also be theta. This is a very basic property that we'll see later also, that for any isosceles triangle, what happens is that the angles opposite to equal sides are equal, okay? These are equal sides. So the angles opposite to these equal sides will also be equal, theta and theta, okay? So that's why this is theta, then this is also theta. Now, how should we name this triangle? In any way, doesn't matter. First triangle can be named in any way whatsoever. Now comes the important part of naming the second triangle. So look, clearly angle P should be equal to angle R. So P should correspond to R. So I have written R here. Now what about the rest of the two? So either Mn will come here or Nm will come here. So if Mn comes, then PL must be equal to Rm. Is it true? PL equal to Rm. Yes, that's true. So Mn will come here. We can't put Nm here because if we put Nm, then correspondingly PL must be equal to Rn, but PL equal to Rn is not true. Okay, it is not given only. And that's why in rough, we already know that this should be the congruence criterion. And of course, what congruence are we using? That this side length, look, we have proved now PL equal to Rm. So this is already equal. And since N is the midpoint, it means that Pn must be equal to Nr because it is the midpoint. So this length equal to this length. So of course, side can only be used. Here also side included angle and side can only be used. So we already know SS must be used. Now, this was in rough. Now in fair we will write. Okay, let me write it like this. This we have done in rough, okay? Already determining the congruence, okay? This is fair, okay? Now again we are writing fair. So look, for SS we should write side 1. Which side is equal? Look, PL equal to RM. Can we say that? Yes. PL equal to RM. Using what? Let us name this equation as 1, that PL equal to RM. And in bracket we write the reason using 1. Okay. Now comes angle. So which angle? Angle P. Yeah, we can just directly write angle P equal to angle R. And reason we will write angles opposite to equal sides PQ and QR will be equal to each other, will be equal to each other. Okay, this is the logic. And finally, the second side that we are talking about is Pn is equal to, now look, Pn should be equal to Rn. So that's how we will write it. We cannot write it NR. We have to write it in that correct order only. Rn only. Okay. Why is Pn equal to Rn? Because n is the midpoint. N is midpoint. Fine. So now we conclude that triangle PLN is congruent to triangle RMN by SAS congruence criterion. Fine. So that's the way we have done. Now using CPCT from here, if we conclude by CPCT, what can we conclude? That LN must be equal to MN, correct? Equal to MN, hence proved. Okay, so I hope that this particular question was also clear to all of you, right? So let's have a look at the solution here. Here also they have used SAS congruence criterion. Okay, and here also they have said that in an isosceles triangle the opposite angles will be equal to each other. And of course they have also taken use of the fact that since these are midpoints, this will also hold true. Okay. And then, of course, at the end, they have used CPCT just the way we have solved it, right? Now, let us talk about this question. In two right triangles, one side of an acute triangle, okay, are equal to the corresponding side and angle of, okay, of the other. Prove that the triangles are congruent. So look, what do we observe in both of these triangles? We observe this angle, this angle, this angle, this angle, and this side is equal. So it is so obvious to see here that S, angle, angle, side. We are obviously not calling it ASA because side is not included, right, between the two angles. So we will call it angle, angle, okay, just a second, angle, angle, side, angle, angle, side, and that's what we are calling. That's correct. So, and now let us try to, in rough, let us also try to write what should be the actual congruence order. So ABC if we write, then congruent to what should come here? Look, obviously this should correspond to D because angle A equal to angle D. So D should come here. Angle B equal to angle E, both are 90 degree. So this should correspond to this. The only thing left is this. So in rough, we already know the order. Now in fair, we will write that we observe that angle A equal to angle D given. Then, so this is the first angle that we are talking about. Second angle now we'll talk about is angle B equal to angle E. Both are equal to 90 degrees, the reason. Okay. Both are given to be 90-degree angles. Now we talk about the side that BC should be equal to EF. Okay, the order is very important. You can't write FE here. You can only write EF. That's why we are in rough. We should already take out the actual congruence. Okay, so let me just write it properly here. BC equal to EF, and reason we can write given. Okay, these sides are given equal. So what can we conclude here? We can conclude that triangle ABC is congruent to triangle DEF using AAS congruence criterion, and hence proved that they are congruent. Okay, so I hope this particular solution is clear to everyone. And here also the same thing has been used. AAS, they have proved that they are congruent. Both are 90 degrees. AB equal to DE and C equal to F. Angle C equal to angle F. Why have they written this? It seems that it is incorrect. They have done a mistake here. Okay. Why are they talking about AB and DE? There is a slight mistake, it seems, but never mind. This solution, I hope, is clear to everyone. Here, I think they have assumed that AB equal to DE and C equal to F. They have assumed that is also fine. Okay. Now, talking about this question, bisector of exterior vertical angle of a triangle is parallel to the base, show that triangle is isosceles. So this exterior angle bisector is parallel to the base. What is the meaning of exterior angle bisector? It means that it bisects the exterior angle. So this complete angle is being bisected by it. So bisect means if this is angle alpha, this angle 2 is alpha, then this angle 1 will also be alpha, because bisect means these should be equal angles. Okay, bisect means it divides in two equal angles. Okay, now if this is alpha, this will also be alpha. Why will this be alpha? Because angle 2 and angle 4 are alternate interior angles. Of course, that's true now, because these two lines AD and BC are parallel. AC is acting as the transversal. So of course, these two angles are alternate interior angles. So we can say angle 2 equal to angle 4. So if this is alpha, this is alpha. Similarly, angle 1 is equal to angle 3, because this line BE is acting as the transversal and they are corresponding angles. Angle 1 and angle 3 are corresponding angles. So they will also be equal. So if this is alpha, this will also be alpha. So this is also alpha, this is also alpha. So this will be an isosceles triangle, because any triangle in which two of these angles are equal, then these sides will also be equal. We already know in an isosceles triangle where two sides are equal, angles are also equal. And if any triangle is there where two angles are equal, then opposite sides will also be equal. Okay. So that's pretty much the solution here. Look, here also they have done the same. Angle 1 equal to angle 2, because it is a bisector, corresponding angles are same, alternate interior angles are same, and hence these opposite angles are same, which means it is an isosceles triangle. Okay, because side lengths will also be equal. All right, here we have another question. PQR triangle is given and PQ equal to PR is given. Any point S on the side PQ is given. Through S, a line is drawn parallel to QR. Prove that PS equal to PT. So this is a very easy question. Look, since these are parallel and since PQ equal to PR, it means PQR is an isosceles triangle. If this is theta, this is also theta. Because we have already seen that in an isosceles triangle, the opposite angles are equal. Now, if this is theta, this will also be theta, corresponding angles. Correct. Of course, these two are corresponding angles, right? And this will also be theta, because these two are also corresponding angles, because these are parallel, right? These two are parallel. So these are corresponding angles with this acting as the transversal. Here, this was acting as the transversal. Here, since this angle equal to this angle, so PST is a isosceles triangle, hence this equal to this. So PS equal to PT has been proved. Okay. So let us have a look at the solution as well. Exactly the same solution we are having, that these two angles will be same. So that's what we did. We assumed them to be theta. Now corresponding angles are equal because these are parallel. So that's what we wrote. So PQR, PRQ. Okay, just a second. PST, PTS are equal, and that's what we have arrived at. PS, okay, PST and PTS angle both are theta. Hence, this will be an isosceles triangle. So the opposite side lengths will also be equal. Hence proved. Okay. So I hope this also is clear to everyone. Now let us have a look at this another very good question. Question is saying line segment joining the midpoints MN of parallel sides AB and DC respectively of a trapezium. Okay, so AB and DC are parallel sides of a trapezium. Let us draw that. AB, CD, these are parallel sides. Okay, and then it is telling us that M is the midpoint of AB, midpoint, okay, midpoint of AB, and N is the midpoint of DC or CD side length. Then we have to, and it is also given line segment joining MN, joining MN is perpendicular to both sides AB and CD. Okay, then prove that AD equal to BC. Okay, so let us join AD and BC. Okay, now we need to do a construction here. Okay, what construction should we do? We do this construction, join this and join this. Now easily we should be able to observe that. Let us first consider these two triangles. Here they have this side common, MN side is common, then this angle and this angle is common, this angle equal to this angle, and finally this side is common. So SAS, it should be applied, right? So let us, I think this one is pretty easy, so we should directly be able to do it without doing the rough work. Also we can do it. That side is first we talk about side AM equal to BM. We can't write MB here, we have to write BM. Okay, angle angle when we are, okay, let us put like this, not equal to, angle AMN must be equal to angle BMN because both are 90 degree. It is given to us, right? And finally we can talk about the final side, which is MN equal to MN, because it is common to both the triangles, correct? So we can conclude that triangle AMN must be congruent to triangle BMN by SS, correct? Because AM equal to BM, angles are equal, then MN equal to MN. So by SAS we have, and of course the angle is included here, right, between both of these sides. That's why included angle has come here in between S and S. Okay. So by CPCT, we can say, by CPCT, we get that AN, now look, first and third letters we have taken, then BN should come, equal to BN. So if so we have proved that AN equal to BN. Now let us consider, and of course, another thing we can say is that angle and angle ANM must be equal to ANM must be equal to BNM. So angle B, okay, let us write this down here. Yeah, and angle ANM must be equal to angle BNM. And let us say this is equal to theta, for example. So this is theta, then this is also theta. Then of course, how much will this remaining angle be? It will be 90 minus theta, because this complete angle is 90, right? So if this much is theta, then remaining will be 90 degree minus theta. Similarly, this will also be 90 minus theta due to the same logic that if we have a 90 degree angle, okay, this is a 90 degree angle. And if we have any line which makes angle theta here, then clearly the remaining angle must be 90 minus theta. Okay, so that's what we are saying. So now look, now consider these two triangles. What will we use in them? Just apply a little bit of brain. This side length is this side length, then this angle equal to this angle, then this side length equal to this side length. So it is so obvious to see SAS should be used. So let us write this down, that DN equal to CN, dn equal to cn, you can say n is midpoint, right? It is given that n is midpoint. So obviously it will divide this DC in two equal parts, okay? Midpoint of CD, you can say. So this is first side that we are talking about. Then we'll talk about the angle. Angle A and D should be equal to B and C. Reason is both are equal to 90 minus theta. Okay, as we have easily proved already. Now side 2 would be, what can we say? AN equal to BN. BN, and logic what will we give? Just name this equation 2. Okay, by CPCT what we had concluded, right? AN equal to BN using 2, using equation 2. So hence triangle AND would be congruent to triangle BNC using SAS congruence criterion. Okay, easily we can observe that that correct order has been maintained. DN CN, CN, yes. Angle A and D equal to angle B and C. Correct order is maintained. AN, AN, BN, BN, yes. So basically I have verified that I have done no mistake in writing these. By CPCT, we can conclude, what can we conclude? That AD would be equal, now AD would be equal to BC, okay? Hence proved. AD equal to BC we have to prove, hence proved we can write. The question is solved. Okay, so I hope this question is also clear to all of you. This was a very good example, no doubt about that. ABC is a right triangle such that AB is equal to AC. Okay, now obviously if AB is, first let us draw a right triangle. Now, if two side lengths are equal there, then of course they have to be both the legs only, because hypotenuse is greater than both the sides, right? So hypotenuse cannot be equal to any of the other sides. So AB and AC must represent these two sides, so that A must be this point, okay? And B will come here, C will come here. You can't put A anywhere else because A is common here. So, and we know that these two have to be equal, right? If you put, let's say, A here, then BC you will put here, but AB can't be equal to AC then, okay? So this we have to think by ourselves, that where A must come, and that in a right triangle hypotenuse is the greatest side, so it cannot be equal to any other side. So these two equal sides must be represented by the two sides or the two legs of the right triangle, okay? And bisector of angle C, bisector of angle C, okay, just a second. Bisector of angle C, let us say, intersects the side AB at D, okay? Let us say it is intersecting at point D. Bisector means if this is angle theta, this is also angle theta, okay? Prove that AC plus AD is equal to BC. Very good question, no doubt about this. Now, one important thing is that let me draw the triangle here. That in the triangle ABC, since these two side lengths are given equal, AC equal to BC, if this is alpha, this will also be alpha, because I have already told you that in an isosceles triangle, the, of course, this is isosceles also because these two side lengths are equal, right? So we can say that angles opposite two equal sides of the isosceles triangle will also be equal. So many times I have told you this property, right? So if this is alpha, this is also alpha. Using angle sum property, I can write 90 degree plus alpha should be 180 degree using angle sum property I have said. And of course, from here you get 2 alpha equal to 90 degree, because 180 minus 90 will be 90. So alpha comes out to be 90 by 2 or 45 degree, correct? So this will be 45 degree, okay? Similarly, this one also will be 45 degree, angle C also. Now comes the tricky part. That tricky part which we should think by applying our brain is to think of this construction. The construction is drop a perpendicular from D onto side BC and name this point as E. Construction. Drop a perpendicular from D onto side BC and let it meet at E. Okay. So that's how we have done this construction. Now, what can we say about these two triangles? It is obvious that both of them are right angled triangles. They also have a side in common, which is the hypotenuse itself, but we don't observe any equal side length. So it means we can't apply RHS. But then what else can we see? That okay, these two angles are also equal. So look, angle, angle, side, this common side between these two triangles, right? So let me make a better diagram. So this side is common here. So what do we observe? Angle, angle, side means AAS must be applied here, not ASA, because side is not included between the two angles. So we can only use AAS. So now I can write, look, in rough, we can already easily work out that the order would be triangle CAD must be congruent to triangle CED. It is very easy to work this out because angle A equal to angle E. So A corresponds to E. So here also E should come, second letter. We can see that this should correspond to both of them because this angle theta, then this is also theta, right? Similarly, CD equal to CD should come, CD equal to CD is coming. So yes, now formally in fair work, what do we write? We write it like this, that first we talk about angle. Angle, what are we saying? First angle will be this, not this, because first this, then this, then this, AAS, not AAS, okay? So this is important to understand that we first should name this angle because it is AAS means what? Angle, angle, and a side uh, which is not included. Okay, so it's better to start with this angle. Angle A equal to angle E, both are equal to 90 degree. This is the reason. Okay, now why is angle E equal to 90 degree? By construction. Okay, now let us talk about angle 2, which is that angle ACD, ACD must be equal to ECD. Okay, equal to ECD. Reason is this is bisecting, right? So let us write this down. CD bisects angle C. Okay, angle C. That's why these it divides into equal angles, right? And finally, we will also talk about, let us write like this. Yeah. Now finally, angle, angle, and side we should write side, that CD equal to CD. Common. This is the common side between both of shared by both the triangles, right? So CD equal to CD. So we can conclude that triangle, what was the name? CAD and okay. So CAD is congruent to CED by AAS congruence criterion. Hence, by CPCT, we can conclude that. What can we conclude? Many things we can conclude. One of the things is that AD, because since we are concerned with AD, right? So AD would be equal to ED. Okay. So AD equal to ED. Let us call this as X for the time being. So if this is X, this will also be X. Now look, in triangle DEB, how much will this angle be? Look, I will draw a better figure here. Triangle DEB, it looks something like this. Okay, let us draw it here. Triangle DEB. Okay, obviously it is already seen that this angle is 90 degree, so that I draw here. Now here it is so obvious to see that 45 degrees here, so I have drawn this also as 45 degree. Then how much will this remaining angle be? use angle sum property. Let's say if this is a beta, then beta plus 45 plus 90 must be equal to 180. Solving this, you get beta equal to 45. So this is equal to 45. It means these two opposite sides angles are equal. So this will be an isosceles triangle, implies triangle DEB is isosceles. Why is it isosceles? Because these two angles are equal, right? So we have already seen an isosceles triangle. What happens? Opposite, a pair of sides should be equal, or a pair of opposite angles should be equal. So isosceles it will be. And since it is isosceles, we can conclude that DE will be equal to EB. Opposite sides will be equal. These are equal angles. So sides opposite to them will be equal. This is a property that we have been using so many times for an isosceles triangle, implies DE equal to EB. Okay, but DE length, DE is already X. DE length is already X here. So what can I say? EB will also be X. Okay, EB will also be X because it is equal to DE only. So EB length is also going to be X. Okay, and by CPCT, moreover, what can we say here? By CPCT, one more thing we can say, that what can we say, AC equal to EC. Okay, AC equal to EC. So let us say this is equal to Y, then AC equal to Y, then EC will also be Y. Now we can easily observe that what is X plus Y? It is easily seen. What is X plus what is this distance Y? Let us see. Implies X plus Y is equal to, we are getting the complete length BC only. Okay, BC. It is so obvious to see that this much portion of the line plus this much portion of the line gives the complete length, right? And complete length is clearly equal to the length of BC only. So that we have written here. Now what is X? X can be written as AD. So AD plus what is Y? Y can be written as AC. So AC equal to BC, hence proved. Hence proved. Okay, AD plus AC equal to BC. So the question has been solved. This was a brilliant question, no doubt, and I hope I have made it clear enough for everyone to understand. Now let us see one more question here. If the bisector of an angle of a triangle also bisects the opposite side, prove that the triangle is isosceles. This is a very good question. Okay, extremely good question. The question is telling us that there is a triangle, let us say ABC. Okay, and it is saying that, let's say this angle is being bisected. For example, this is theta, then this is theta, and this bisector, this angle bisector also bisects. Okay, just a second, let me draw a better diagram. Also bisect the opposite side. Yes, so it means that this side is also bisected here. Prove that this triangle is isosceles. Now many students do a very big mistake here. What they say is, in these two triangles they consider this side length equal to this side length is common, and this angle is equal. So they apply SAS, but that is incorrect. In SAS, what should happen? The angle must be included between the two sides. Here, between this side and this side, do you see the angle is included? No, the angle is somewhere else. So we cannot apply SAS. We will have to apply side angle, SSA, because look, side, and then angle. Here also side, and angle. So we can only apply SSA. But there is no such criterion by the name of SSA. So all the techniques fail here. We cannot apply any congruence criterion between these two triangles. We simply cannot apply. SAS fails because angle is not included. SSA fails because there is no such criterion like SSA. Then what can we do? So now we will have to apply a lot of brain. We will have to think a lot. And And we will have to think of a clever construction. And what is that clever construction? Let me tell. Okay, let me tell what is that clever construction. So what we are saying is that these two are equal. Okay, BD and CD are equal. Now the construction that we will do is we will extend this AD line. Okay, construction I'll write here, construction. Extend AD to a point E such that AD equal to DE. So till how much are we extending? We are extending till a point E such that the length DE must be equal to length AD. So this length equal to this length. This is the construction that we have done. Now join points EC and now observe that, okay, let me just do one thing. I'll write this properly here. Yeah, let me write this properly that this angle is theta here. Okay, now observe between these two triangles, these two angles will be equal because they are vertically opposite angles. This side length, okay, this side length AD, okay, it becomes very hard to draw, so I will just draw once again. And this side length AD is equal to, this side length is equal to what? It is equal to this side length of this triangle. And finally, this side length is equal to this side length. So SAS we can apply in these two triangles, right? So, and let us try to name in rough already how we should name these triangles. Triangle ADC. Now look, since angle D is common between them, D must come in the second position here, then D will come here because they are corresponding points for both triangles. Now, what should come here? Let's say we name this triangle. Either you will name EDC or you will name CDE. If this is the way we name it, then AD must be equal to ED. AD equal to ED is true, so this is correct. This is incorrect because AD must be equal to CD here, but AD and CD are not equal, so this is eliminated. So using this rough trick, we have already known how it should come. Now, formally we will write that first of all, we'll talk about side because we have already seen SAS will be applied here because the angle is included here between both of these sides. So we already know SS will be applied. So first we'll talk about a side. So we will say about, let's say this side. So let us say, I think we have written the name incorrectly. Here we should write ADB, not ADC, of course. Okay, so BD will be equal to what? CD. And of course, that is true here because BD is equal to CD. Reason we can write D bisects. Okay, it is given now in the question that D bisects, or we can write AD bisects side BC. Okay, so obviously BD will be equal to CD. Now comes angle. Angle, how will we write? Angle, we just can't write angle D alone because then it will be confusing. This angle D, this angle. Look, if this is the point D, angle D can mean this also, angle D can mean this also, angle D can mean this also, angle D can mean this also. So we can't just write D. We will have to name the complete angle. So angle ADB equal to angle EDC, and what logic will we provide? Vertically opposite angles are equal. And finally, side, the final side will be AD. From here AD if I am taking, then what will come from here? First like in second letter, first letter, second letter. So ED, is it true? Yes. And logic, what reason, what will we provide? By construction. We have constructed only like this. Okay, so by construction, so implies triangle ADB is congruent, okay, is congruent to triangle EDC by what criterion? SAS. And once we have proven them to be congruent, CPCT, what can we conclude? CPCT will imply angle. Now look, I want to talk about this angle because this is the only angle that we know the value of, which we have assumed to be theta. So angle BAD, BAD will be equal to what angle? BAD will be equal to CED. Okay, third letter, first letter, second letter. So CED. So since BAD is equal to theta, this will also be theta. So CED angle will be theta. Now look, this implies that triangle AEC is isosceles. Why is it isosceles? Because these opposite angles are equal. No, this is also theta, this is also theta. And if AEC is isosceles because of the opposite angles being equal to theta, we can conclude that opposite sides will also be equal. So AC will be equal to EC, hence proved. Okay, what we are saying here, we are saying that AC equal to EC. Okay, right now the proof is not complete, sorry. We have only proved AC equal to EC. And from CPCT, another thing we can conclude is CPCT that EC will be equal to AB. Okay, will be equal to AB. And from here we have proved AC equal to EC. So EC equal to AB also, AC also. So we can say that AC will be equal to EC. Sorry, AB. Are you all getting it? What we are saying? EC is equal to AC also. EC is equal to AB also. So obviously AC and AB will be equal to each other also. Na? Okay, because using the Euclid's axiom, if two things are equal to the same thing, then they are also equal to each other, right? So AC will also be equal to AB. And since AC and AB are equal, we can conclude that the triangle ABC is isosceles because it has a pair of equal sides. Okay, so no doubt a very good question, and many a time students incorrectly apply SAS or SSA, which is not the correct way to solve it. So I hope you were able to understand this very properly. Here we have a very good question. We are given that PQRS is a square and SRT is an equilateral triangle. Prove that PT equal to QT and angle TQR also we have to find. So look, it is very easy. Consider these two triangles. Okay, this triangle and this triangle we can consider, and it is so easy to see that. Okay, let me just erase this. Otherwise, it might be a little bit messy. So what we are saying is this is 90 degree, and what will be this much? 60 degree, right? So this entire angle is 150 degree. 90 plus 60. This is also 150 degree because in any equilateral triangle, every angle is 60 degree. Square 90 degree. 90 plus 60, 150 degree, right? Now, of course, this length equal to this length. What is the reason? Opposite, all the side lengths of our square are equal. Why are these two side lengths equal? Equilateral triangle, all side lengths will be equal. So side angle side. So that's it. So now we can say that PS equal to QR. Sides of square are equal. Then angle we will talk about. Angle. Which angle will we talk about? Angle PST will be equal to angle QRT, and logic, what will we say here? Reason. Same reason we'll provide that. Not same, we'll say both are equal to 90 degree plus 60 degree equal to 150 degree. Finally, the side we will talk about that TS is equal to TR. Okay. Reason is sides of equilateral triangle are equal. Triangle are equal. Hence, by hence we can say triangle PST will be congruent to triangle QRT. It is very important to name it correctly. Okay. Why does point S correspond to R? Because obviously both of these angles are equal, right? So S will correspond to R only, right? And similarly, T point will correspond to T, and similarly the remaining letter P and Q we write as it is. So and what is the logic that we have used there? Criterion we have used SAS criterion. So by CPCT, we can conclude that PT. So look, PT will be equal to QT. Okay, equal to QT. These correspondence orders are very important. That's why. Okay, PT equal to QT. Hence proved. Okay, the first part has been proved. What about this second part? How will we find the value of this angle? So observe that uh, TQR angle we are talking about, right? So since this is an equilateral triangle, TR will be equal to RS, because in equilateral triangle all side lengths are equal. So TR will be equal to SR also, right? And we know that SR will be equal to RQ. RQ. Why? Because in a square all the side lengths are equal. So this side length will be equal to this side length also. So we get that TR equal to RQ. If now let me draw this again. So now TR equal to RQ means triangle TRQ is isosceles. Correct? Why is it so? Because two pairs of side lengths are equal. So angles opposite to them will also be equal. So if this is theta, this will also be theta. And what? How much was this angle? 150 degree, right? Apply angle sum property. What do we get? We get 150 degree plus theta equal to 180 degree. Solving this, we will get theta equal to 15 degrees, and TQR is obviously theta only, and hence we have found the value. Let us have a look at the second question. In an isosceles triangle, if the vertex angle is twice the sum of the base angles, calculate the angles of the triangle. So let us say if we have an isosceles triangle, let's say the base angles are theta, then other will also be theta only, because base angles will be equal in an isosceles triangle, and the vertex angle is twice the sum. Okay, so let us name this vertex angle x. X is equals to twice the sum of the base angles. So sum is theta plus theta. It will give us 4 theta. Okay, so calculate the angles of the triangle. Using angle sum property, we can say x plus theta equal to 180 degree. This becomes 2 theta plus 4 theta. I have put the value of x. This becomes 6 theta. So theta comes out to be 180 degree by 6, which is 30 degree, because 180 degree equal to 6 theta, right? So theta will be 180 by 6. Theta comes out to be 30 degree. So what will be the angles? X will come out to be 120 degree. So angles will be theta theta x, or 30 degree, 30 degree and 120 degree will be our answer. Okay, so I hope you all were able to understand these answers, and of course we have the same answers here as well. So I hope you all enjoyed watching this lecture. Thanks a lot for watching, and I hope you enjoyed watching the lecture itself, because we learned a lot of new concepts using, in fact, the applications of these criteria on using on different questions. So I hope you were able to understand those. Stay safe and enjoy. And once again, thanks a lot for watching. Bye bye.